All right. Hello, everyone, and welcome to our discussion on comparing linear, exponential, and quadratic functions. In other words, we're talking about linear versus nonlinear functions. So, here are a few vocabulary terms as we get started. The first one is a parent function, and a parent function is the most basic function to which a family of similar functions originate from. We're going to talk about a few parent functions today, but parent function is like the parent, and you have all the children. Okay, so all the different versions of it. So, for example, you might have a linear function that looks like this, and a linear function is a graph. It's a function whose graph is a straight line. You could also have a linear function that looks like this. You can have a linear function that looks like this. This is what we call a family of functions. Okay. They're all similar, but they're all different. So that's why we have a parent function, which is a basic, and then we have a family of functions. So here's a parent function of a linear function. So here's a parent linear function. The equation of a parent linear function is f of x equals x or y equals x, and it looks like this. The domain is from negative infinity to infinity. The range is also from negative infinity to infinity, and we'll talk more about the domain range when we get into characteristics of functions. The x-intercept, where it crosses the x-axis, is at 0, 0. And then it also intercepts the y-axis at the same point. This is your x-axis. This is your y-axis. This function is increasing. It's always increasing, which is why it's negative infinity to infinity, increasing as we look at the graph from left to right. And then the end behavior tells you what the graph is doing at the end of at the end of the graph. Okay. So as x approaches infinity, that means you're looking at the right side of the graph, and we'll talk more about this later. But if you're looking at the right side of the graph, as x is approaching infinity, our graph itself is also approaching infinity. And then as x is approaching negative infinity, see that negative there? That means this is the left side of the graph. Our function is also approaching negative infinity. These are just some of the characteristics of a parent linear function. Again, this is just an overview. We won't be getting into that in much detail today. So today, though, what I want you to be able to walk away with is what are the differences between a linear, quadratic, and exponential function? So here they are right here, okay? A linear function is of the form y equals mx plus b. You might remember that from middle school. An example of this is y equals 2x plus 3. The linear function is a straight line, okay? Here we have a quadratic function. Y equals ax squared plus bx plus c is the standard form. And it's a U-shaped graph. And this is an example of it. Y equals 2x squared plus 3x plus 1. The highest exponent on a quadratic is 2. Notice that's the exponent. The highest exponent in a quadratic function is 2. And all quadratic functions are U-shaped. Now, the U-shape could be right side up like this one is, or it could be upside down. Okay. So it could also be upside down, but it's a U-shaped graph. If you see a U-shaped graph, it is quadratic. Okay. So if you see a U-shaped graph, whether it's upside down, shifted around, it is a quadratic function. And if you see a line, no matter which way the line is, if it's a straight line, it is a linear function. Now, exponential functions are curved. It's kind of like a slide, okay? And it's of the form y equals ab to the x. In this case, the x is the exponent, okay? So sometimes it looks like this. Sometimes it could be flipped upside down like this. Sometimes it looks like this. If it's shaped like a slide, it is an exponential function, okay? So these are the three basic functions that we're going to be talking about in algebra. So I'm introducing you guys to the three functions we're going to be talking about the most in algebra. Linear function is a straight line. Quadratic function is a U-shaped graph, upside down, right side up, It doesn't matter. An exponential is like a slide. Okay, it's a slide. Upside down, right side up. That's what an exponential function looks like. So identifying it from an equation. So we just looked at it, identifying it from a graph, but here's how you would look at it from an equation. Here are examples of linear functions. It has an x with no exponent on it, or the exponent is 1. Okay, you don't see a number here, but the exponent is 1. So here's an example. Y equals 5x plus 1. That's a linear function. Y equals 1/2 x. That's a linear function because the has an exponent of 1. 2x plus 3y equals 6 is also a linear function because the x has a highest exponent of 1, and there's no exponent on that y either. An exponential function has an x as the exponent. Y equals 3 to the x. The x is small, plus 1. Y equals 5 times 5 to the 2x power. So you can have a 2 there with the x, but as long as the x is an exponent, it's exponential. 4 to the x plus y equals 13. All of these are examples of exponential functions. And here's a quadratic function. Y equals ax squared plus bx plus c. It has an x squared in the equation. The highest exponent is x squared. So for example, y equals 2x squared plus 3x minus 5. Y equals x squared plus 9. X squared plus 4y equals 7. So these are examples of quadratics. So take a look at them, write them down, make a table, make 3 columns so you can characterize linear, exponential, quadratic, compare them. Okay. Now let's take a look at them from the tables. Linear functions have a constant rate of change, unlike nonlinear functions. Okay. So we already know this first graph. We already know this first one is a linear function because it's a line. We see it. It has a constant rate of change. So let's calculate that right here. So if you look here, the change in y, this is going up by 1, plus 1, plus 1. And here, 6 minus 2 is plus 4, plus 4, plus 4. So the slope here, remember, slope is y2 minus y1 all over x2 minus x1. That's from middle school. So if you subtract the change in y, that's going to be 4 over 1. Okay. They also are slope m equals 4. So it has a constant rate of change. This is an exponential function. They have what we call a common ratio. So this is still going up by 1, plus 1, and plus 1. But here, you notice this says if I do 6 minus 2, I get 4. If I do 18 minus 6, I get 12. And then if I do 54 minus 18, I get 36. All right, so it does not have a constant rate of change. It has a variable rate of change. Anytime there is a variable rate of change, it is nonlinear. And you can look at the graph and see that it's nonlinear. Okay, so when your rate of change is not the same, we call that nonlinear. All right, so now let's put it into practice. Go ahead and pause the video, try this out yourself, and then come back. And if you're not sure what to do, maybe putting it in decimals might help. Welcome back. I hope you paused the video. Classify each equation as linear, quadratic, or exponential. And again, pause the video if you didn't do it and give it a try. So first one, you have f of x equals 3x plus 2. When you look at it, the highest exponent here is a 1. This x doesn't have an exponent on it, so we call that linear, and the x is not an exponent. Here, you see the x is an exponent, so we call that exponential. Here we have f of x equals 2. There's actually no variables here. So we would classify that as neither. I cannot spell. Don't judge me. I cannot spell today. 4 times 2 to the x power. Wait, f of x equals 2. Let's see. I could actually graph a line with that. Hold on. All right, so this first one we said is linear because that's 3x plus 2. This next one we said is exponential because that x is an exponent. This one I was going to say neither, but if I graph it, f of x equals 2. So let's go ahead and grab our calculator here, our Desmos calculator. Hold on a second while I pull that over. And you would have said neither because you probably would have thought neither because it didn't have any variables at all, but it does have a constant. So let's go ahead and say f of x. So you can put that in your calculator like that. No spaces equals 2. When you graph it, guess what? We do get a line. It's just a constant line, okay? It's just constant, it's not changing. So this is linear. All right, this one, the x is an exponent, so this is exponential. This one, the x is an exponent, so this is also exponential. And then finally, we have the highest exponent here is 2, so this is what we call quadratic. All right, so this is identifying types of functions from an equation. All right, how about from a graph? All right, we're going to say E if it's exponential, L if it's linear, Q if it's quadratic. Go ahead and pause the video and or end it and end if it's neither. All right, so go ahead, pause the video and give it a try. Welcome back. This first one looks like it is exponential. It's a nice slip and slide. This one is a linear function because it's a straight line. This one is also exponential. Even though it's upside down, it's still a slide. This one is linear. It's a straight line. This one is a quadratic. It's a U-shaped graph. This one is linear. This one is neither. And this last one is exponential. All right. Hopefully you're getting the hang of comparing linear, exponential, and quadratic functions. How do we do it from a table? Remember, linear functions have a constant first difference. What I did not tell you that you will explore later, quadratic functions have a constant second difference, and exponential functions have constant ratios. But what I want you to do is identify which one of these tables is linear. All right. Pause the video, give it a try. So that means you're going to go ahead and see what the change here. This one is going up by 1, plus 1, plus 1, plus 1, plus 1, plus 1, right? That's what's going on the right-hand side. What about for the y's? As that's going up, this one is going negative 1 minus, so that's -1 minus -3, which same thing as -1 plus 3. So that's going up by 2. 1 minus -1, that's going up by, I said 2 and I wrote 3, plus 2. That's going up by plus 2, plus 2, plus 2. So our slope, which is the change in y over the change in x, 2 over 1. And the slope is constant. It's the same. Okay? The slope is the same, minus my chicken scratch. So this one is what we would call a linear function. Here, this one is also going up by 1. But this one is going down, down by 5, then it's going down by 3, down by 1, down by 0. Wait, up by 1, and then up by 3. So this one is nonlinear. And we'll talk more